Hello everyone! Today's topic is going to be triangles, but not just any triangles. The point of this presentation is to get you familiar with the concept of a right-angled triangle, as well as a related mathematical theorem with far-reaching applications. Let's get started. In mathematics, a theorem is a statement that has been proven true by deductive reasoning. It's sort of like a scientific theory, except it isn't based on experiments. The subject of this video, Pythagoras Theorem, is a statement about objects that look like this. These are triangles that each contain a 90-degree angle, represented by the tiny squares. 90-degree angles are often called right angles, making these shapes right-angled triangles. Within a right-angled triangle, there are three sides of unequal length. The longest side is always the one opposite the right angle. Don't believe me? Draw a few of these triangles and measure them up. You might surprise yourself. In technical terms, that long side is called the hypotenuse. I used to call it the hippopotamus side until I could spell hypotenuse correctly. You can see right-angled triangles all over the place if you look hard enough, especially in cities. Consider a vertical wall standing on horizontal ground, for instance. If you were to rest a ladder against that wall, it would form the hypotenuse of a triangle, whose other sides are defined by the wall and the ground. Down here is the right angle. For another example, consider a zipline that stretches from the top of a tall tree to an anchor on the ground. As you zoom down the zipline, you're traveling along the hypotenuse of a very big right-angled triangle. Right-angled triangles have been studied for at least 3,800 years, when the ancient Babylonians were interested in them. They are now most closely linked with the philosopher Pythagoras, who lived in Greece around 2,500 years ago. He had a lot of mystical ideas. For example, the idea that humans could reincarnate as beings after they died, as well as brilliant mathematical ideas, including this theorem. It links the length of the hypotenuse to the lengths of the other two sides in a right-angled triangle. As an equation, the theorem can be written as c squared equals a squared plus b squared. Each letter represents a number, the length of one side of the triangle. Every one of them is being squared, which means it is being multiplied by itself. The letter C is a stand-in for the hypotenuse. The other letters represent the other two side lengths, and their order does not matter. I suggest you pause this video for a moment to inspect the diagram closely. Even knowing what this equation stands for, the best way to understand it is to see it in use. In a common situation, you may have measured the two shorter sides of a right-angled triangle, and you want to know the length of the third side, the hypotenuse. Let's suppose the length A is 3 meters and the length B is 4 meters. To figure out the length of C, the hypotenuse, we start by substituting those numbers into the equation. Okay, now we need to square those numbers individually. 3 squared is 9 and 4 squared is 16, as you should remember from your times tables. Next, we add these together to get 25. It looks like we're almost done, but there's still one more step. We've just calculated c squared, which is the length of the longest side multiplied by itself. The problem is we just want plain simple c. Getting it requires a little bit of algebra. We now need to do something to both sides of the equation in order to reduce c squared to c. In other words, we need to undo the square function. Do you remember what undoes a square? If you said square root, that's right. A square root is the inverse of a square. It's represented by this funky looking sign on your calculator. We can take the square root of c squared to get c by itself. However, by the laws of algebra, we have to do the same thing to the other side of this equation. That means we also take the square root of 25. It turns out to be just 5, leaving us with c equals 5. Therefore, the length of the hypotenuse for this triangle is 5 meters. That's the answer we wanted. Pythagoras' theorem would not be so well known if it weren't so useful. Mathematicians, physicists, and engineers are the people most likely to use it in daily life, but it's a helpful tool for all kinds of scientists, even a humble geologist like myself. You can use it to predict where mineral veins lead under the Earth's surface, or even find the probability of a deadly landslide happening. As a final example, I recently created a video about vectors and the way they are added or subtracted. These are essentially arrows that have a certain magnitude and direction, which represent physical quantities like force or velocity. When vectors are placed at right angles to each other, then added, you use Pythagoras' theorem to calculate their total magnitude. If you plan to study physics, you're going to become very familiar with this formula. The last thing I should mention is that calculating lengths using Pythagoras' theorem hardly ever gives you neat whole numbers like this. Often the answer you want is an irrational number that runs on infinitely long after the decimal point. This is normal and nothing to worry about. You simply round the answer and put some units on it. I like to round to 2 decimal places, but your teacher may tell you to do something else. Well, I think I've said enough at this point. I'll stop prattling and show you a few practice problems instead. Grab your calculator and pause the video when each new question comes up. Try to find the hypotenuse of each triangle shown, then press play again to see the correct answer. Feel free to ask any questions in the comments below, and good luck.